Good morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about the inverse transformation examples. In the last class, we discussed about the inverse transformation one method, that is power series method or the long division method. Now, you can see the next method, the second method is a partial fraction expansion method. In this also, we already did one example. The three cases we have. First case is distinct poles. About the different poles we get, how we can find out the inverse transformation using the partial fraction expansion. If there is any repeated poles, we can follow this procedure. Find out the inverse transformation for the given function x of z by using the partial fraction method. And the third case, if having the complex poles, you can use this procedure to find out the inverse transformation of the given function by using the partial fraction method. These three cases we know. And in the yesterday class, the last class, we explained this. Find the inverse transformation of the below function, the z inverse by the 3 minus 4 z inverse plus z power minus 2. Z is greater than 1. Z is greater than 1 case. First of all, if any given function x of z is in the negative powers of z, convert into the positive powers of z. Then bring the function x of z is the x of z by z. Then you can write this as a roots to find out the a value and the b value of the c1 and the c2 according to our choice. So we already find out the x of z by z with the a value is 1 by 2 and the b value is a minus 1 by 2. So 1 by 2 into 1 by z minus 1 minus 1 by 2 into z minus 1 by 3. And the left hand side, the function x of z is a x of z by z. Bring that z towards the right side as a cross multiply. 1 by 2 z by z minus 1 minus 1 by 2 z minus 1 by 3. In the first case of ROC, z is greater than 1. It is very important to write the inverse transformation after partial fraction expansion. Z is greater than 1 is all the functions you can write as towards the right side. Towards the right side. According to that, it is a z is greater than a. We know the a power n mu of n, and z is less than a minus a power n mu of minus n minus 1. So the constant is 1 by 2. The inverse transformation is 1 by 1 minus z inverse. Here the a is a 1. A is a 1. Actually, the a power n mu of n z transformation is in the positive powers of z here. The positive powers of z is z by z minus a. What is the a here? 1. So 1 power n mu of n as per z is greater than a. We're taking the 1. And the second function, the minus 1 by 2, it is also in the greater than only. What is the a here? Z minus z minus z by z minus 1 by 3. A is a 3. So 1 by 3 mu of n by 3 whole power n mu of n. So simplifying, the x of n is equal to 1 by 2 whole multiplied with 1 minus 1 by 2, 1 minus 1 by 2 whole power n mu of n. 1 by 2, 1 minus 1 by 2 whole power n mu of n. Got it, my dear students? So in this function, we substitute that a is equal to 1 by 2 we got, and b is equal to minus 1 by 2, and x of z by z is equal to 1 by 2 by 1 minus z minus 1 minus 1 by 2 1 by z minus 1 by 3. For the ROC given the z is greater than 1, ROC z is greater than 1, use this function use this function as a power n mu of n is z by z minus a. And to the greater than the a value, minus a power n mu of minus n minus 1 is less than a when you are using the z by z minus a, the same function. So 1 by 2, the z inverse of z by z minus 1 is a 1 power n mu of n. And z by z minus 1 by 3 is 1 by 3 whole power n mu of n. Okay. And the second case, the ROC, if the question ROC is z is less than the 1 by 3, less than the 1 by 3. The first case you can consider, and this one is the second ROC. What you have to do here? Greater than is nothing but a power n mu of n we take. And now the less than value means all the values you can write it as a minus a power n mu of minus n minus 1. So what is the inverse Z transformation of z by z minus 1 is nothing but minus of 1 whole power n mu of minus n minus 1. And z by z minus 1 by 3. Here a is a 1 by 3. So minus of 1 by 3 whole power n mu of minus n minus 1. So take the 1 by 2 is a both of the common. Already we have here the minus is there. Minus into minus is a plus. Write the first term as a 1 by 3 whole power n minus 1 power n. So 1 power n, anything power n is a 1 power anything is a 1 only. Into mu of minus n minus 1. This is x of n. X of n is equal to, when the ROC is z is less than the 3. Z is less than the 3. Both inside the circle. Greater than means outside the circle. See, that is inside the circle with the radius of z is 1 by 3. With radius 1 by 3 here. So totally inside the circle only. The ROC is inside the circle. Is a region of convergence. Okay. And here, but this ROC is outside the circle with the radius of 1 outside the circle here. Is the ROC of z is greater than 1. Now in the third case, you can observe, what is the third case? 1 by 3 less than z less than 1. So 1 by 3. There is a third case, my dear students. Here the third case. One by 3 less than z less than 1. So what is the two functions here? Z is greater than 1 by 3 as one ROC and z is less than 1. Okay. By using these two functions, the range is 1 by 3 less than z less than 1. So z is greater than 1 by 3, you can write z is less than 1. Z is greater than 1 by 3. So for the function where we have the 1 by 3 value is there, we can write that as 1 by 3 whole power n mu of n. And in the function where the value is 1, in that you can write as a minus of 1 power n mu of minus n minus 1. Okay. So the x of n is equal to 1 by 2 and z inverse of not the z inverse, the z transformation, inverse z transformation is z by z minus 1 as minus of 1 power n mu of minus n minus 1 because it is a less than. Minus is already there and here the 1 by 2, take the common, z by z minus 1 by 3 because it is a greater than, you can write as a power n mu of n. The two functions. Now for the third case, time domain function is x of n is equal to 1 by 2 whole multiplied with the first function is minus of 1 power n mu of minus n minus 1 minus 1 by 3 whole power n mu of n. But what is ROC here? Because the two circles we have, the two circles, first of all, let's take greater than 1 by 3. greater than 1 by 3. So 1 by 3 is compared to the value here. Take the radius and these two. So I will explain this what they are. You see here in the question, z is less than 1 by 3 and the z is greater than 1. See, it is not the less than, it is a greater than 1 by 3. See, if it is a less than 1 by 3, greater than 1 by 3 is whatever we did greater than 1 by 3 with the radius of 1 by 3 here. Another circle you have to draw with the radius of 1. In the previous case, 1 by 3 is greater than, it's outside the circle of 1 by 3. It's outside the circle of 1 by 3. Okay. Outside the circle of 1 by 3. And this function is less than 1 for the first term. Less than 1 means with the radius we have inside the circle. That I am taking the inside. So total circle is covered here. But what is the actual region of convergence? Wherever it is overlapping is there for the greater than 1 by 3 and the less than 1 by 3. This is a region. This is a region what we have inside. Okay. This is a region. Intersection region is a ROC, a region of convergence for 1 by 3 less than z and less than 1, because z is greater than 1 by 3 and z is less than 1 up to this case. And the fourth case, they are assuming that z is less than 1 by 3 and z is greater than 1. So z is less than 1 by 3. Suppose inside the circle, if I am taking the radius of 1 by 3, 1 by 3 radius, inside the circle means inside the value here. And z is greater than 1. Z is greater than 1. You can draw the circle with the z is greater than is the radius of 1. Z is greater than, the circle means is outside the ROC. Outside the ROC. So observe in this condition, the inside the ROC is less than the 1 by 3. ROC is greater than 1 in the region. Okay, my dear students. Means 1 with less than z less than 1 by 3. In this region, we have means z is greater than 1 and z is less than 1 by 3. There is no any ROC will get because no overlapping occurs, but z is greater than 1 and z is less than 1. No intersection is occurs here. Then there is no common region. Then there is no common region, so the inverse Z transform is not possible here. For the fourth case. But the third case, there is an intersection is we have. Z is greater than 1 by 3 and Z is less than 1 by 3. If suppose here the range is different, Z is greater than 1 and Z is less than 1 by 3, it is not possible to find out the inverse Z transformation. Can find, but there is no any ROC. The common ROC is not there. The common region, simply saying there is no any common region when we use the range 1 less than z less than 1 by 3. Got it, my dear students? Now to take another example, x of z is equal to z by 2z square minus 3z plus 1. X of z is equal to z by 2z square minus 3z plus 1 and ROC is less than 1 by 2. So already the given function is in the positive powers of z, no need to convert. Take the function given x of z as x of z by z, x of z by z, and 1 by z square minus 3z plus 1. Find the roots. That roots we got, it is z minus 1 into 2z minus 1. The two factors. So 2z square minus 3z plus 1. So by using this minus b plus r minus square root of b square minus 4ac by 2a, or directly you can find out the roots, whatever you can. X of z by z is 1 by z minus 1 into 2z minus 1. So the x of z by z, 1 by 2, 1 by z minus 1, 2z minus 1 is equal to a by z minus 1 plus b by 2z minus 1. Find the a and the b values by comparing the. I would compare, or otherwise you can use the a is equal to z minus 1 into x of z by z using the formula z minus 1 x of z by z, where z substitute the z is equal to 1. Similarly, to find the b, 2z minus 1 multiplied with x of z by z, substitute the z is equal to 1 by 2. Or otherwise, you can use a1 is equal to a into 2z minus 1 plus b into z minus 1. Z minus 1. Now compare the equations, or you can substitute z is equal to 1, b will be 0, z is equal to 1, b, the term, second term, it becomes a 0, a into z is equal to 1 means 2 minus 1 is a 1, a is equal to 1. So already we got the a is equal to 1 here. Now compare the coefficients, the constants or the coefficients. If I am comparing the z coefficient, the left hand side there is no any z term, the right hand side the 2a plus b. So already we got the a is equal to 1. Already we got with a is equal to 1. Substitute a is equal to 1 here. B is equal to minus 2. B is equal to minus 2. So x of z by z is equal to a, we got the 1 by z minus 1, minus b will got the 2. So plus into the minus, actually the minus 2 by 2z minus 1. Okay. So in the left hand side, x of z by z is there. Cross multiply the z. X of z is equal to z by z minus 1 minus 2z by z minus 2z by 2z minus 1. Take this 2 as a common here. Z minus 1 by 2. 2 to get cancelled. Okay. Now it is in the form of z by z minus a. Z by z minus a is a power n mu of n when the greater than value. And z by z minus a when it is ROC is a less than, it is a minus of a power n mu of minus n minus 1. So z by z minus 1 minus z by z minus 1 by 2. If ROC is less than 1 by 2, less than 1 by 2 means minus of a power n mu of minus n minus 1. Less than, because it's the left hand side. So the inverse transformation of z by z minus 1 is the minus a power n mu of minus n. Substitute. And similarly, the z by z minus 1 by 2 is a is 1 by 2 here. So you can get the equation x of n is equal to, when it is a less than ROC. So irrespective of value, if it is a less than means both the functions you can write in the left hand side. It is the first function is a 1, so minus of 1 power n. Already we have the minus is there, minus into minus is a plus, and 1 by 2 whole power n whole multiply with the mu of minus n minus 1. This is the inverse transformation of the given function z by 2z square minus 3z plus 1. When ROC is a less than 1 by 2. So first function is a minus of 1 power n mu of minus n minus 1. And for the second function, minus 1 by 2 whole power n. Already the minus into minus is a plus, mu of minus n minus Okay. So we got the same function 1 by 2 whole power n minus 1 power anything is a 1 only, mu of minus n minus 1. Got it, my dear students? The next example here. Next example, x of z is equal to z plus 1 into z plus 5 whole divided by z plus 2, z plus 3 and the z plus 6 with ROC is less than the 2. Now, x of z by z, there is no any z here. After converting the given negative powers is there, first of all you can do positive powers and bring the x of z function as x of z by z. There is no any z to get it is a x of z by z. So multiply 1 by z on both sides. So x of z by z is equal to 1 by z into the given total function. By using the partial fraction expansion method, denominator we having the 4 terms are there: a by z, b by z plus 2, c by z plus 3 and d by z plus 6. Find the a value, b value, c value and the d value according to the distinct poles what we have. The procedure is there. That is z into x of z by z, substituting z is equal to 0. To find the b, whatever the denominator is there, take that denominator z plus 2, multiply with x of z by z, the total function, substituting the z is equal to minus 2. To get the c is equal to, whatever the denominator we have here, take the denominator z plus 3 and multiply this total function x of z by substituting the z is equal to minus 3. And the last one, the d is equal to also, whatever the denominator we have for the d, take the denominator z plus 6 and multiply with the x of z by z, the total function. In that, the z plus 6 can get cancelled. Here the c, z plus 3 cancel. Substitute the whatever the remaining function we have, the z is equal to 0, z is equal to minus 2, z is equal to minus 3 and z is equal to minus 6. After that, the a value we got the 5 by 36, b value is 3 by 8 and c value is equal to minus 4 by 9 and d value is equal to minus 5 by 72. After cancelling the z plus 6, whatever the function we have, z plus 1, z plus 5, z plus 2 and z plus 3, and substituting the value, you'll get the minus 5 by 72. So write the a, b, c, d value in this function. A as 5 by 36 into 1 by z, 3 by 8 into 1 by z plus 2, minus 4 by 9 into 1 plus 1 by z plus 3, and minus 5 by 72 into 1 by z plus 6. But in the left hand side is x of z by z is there. Cross multiplying the z in the right hand side, the z cancel, z by z plus 2, z by z plus 3, z by z plus 6. Now it is asking that the ROC is a less than the 2, irrespective of the value. You can see that is a less than only. Less than means including all the functions you can write as a minus a power n mu of minus n minus 1. But here the first function, there is no any term of the z by z plus a. Okay. Z by z minus a, not the z plus a. Z by z minus a is there only. It is a function a power minus of a power n mu of minus n minus 1. So I convert this as z of minus 2, z of minus 3, z minus of minus 6. Okay. The first term, here the inverse the transformation of 1 is the delta of n. So 5 by 6 into delta of n. The coefficient is a 3 by 8. Z by z minus a. A is a minus 2. It is not a minus of here, my dear students. Okay, minus 2. A is a minus 2. Minus 2 whole power n mu of minus n minus 1. Minus 4 by 9 in the function minus 3 whole power n mu of minus n minus 1. and the last function minus 5 by 72 minus of minus 6 whole power n v of minus n minus 1. This is total equation for the given total equation x of z is equal to z plus 1, z plus 5 whole divided by z plus 2, z plus 3 and the z plus 6. Okay, for this function x of z, x of n we got as the inverse transformation for the x of z, 5 by 6 delta of n, 3 by 8 and minus 2 whole power n v of minus n minus 1, minus 4 by 2 multiplied with the minus of minus 3 whole power n v of n minus n minus 1, and minus 5 by 72 whole multiply with the minus of minus 6 whole power n v of minus n minus 1. Got it, my students? We go for the next example. See, there are different types of the same type of the examples we have here. We do this as x of z is equal to z plus 1 by z plus 2 into z minus 0.6. Write it as a by z plus 0.2 and b by z minus 0.6, and simplify the a and the b values and find the inverse z transformation. And for this case also, the same thing, 6z cube plus 2z square minus z by z cube minus z square minus z plus 1. So actually these are both numerator and denominator. Numerator order is 3 and denominator order is also 3. Okay, convert these as denominator order and numerator order is increasing. Means you can multiply the z is there in the upwards. Multiply the z, you take the z by z here and simplify. And for the third also, the 1 by z square minus 12z plus 0.2, write as a factors and find the inverse z transformation. So I will explain here. There's another example here. You do these three, practice these three examples. And another example, you can take x of z is equal to 1 plus z inverse by 1 minus 2 by 3 z inverse whole square, 2 by 3 z inverse whole square. So from here, the numerator, you take the z inverse as a common, 1 by z inverse, it becomes of z plus 1. And in this also, you can take the z inverse as a common, inside the parenthesis, 2, not the 2, z minus, because it's a 1 by z inverse is nothing but the z, minus 2 by 3 whole square. Okay. And now the z inverse whole square means z power minus 2, and here the z power minus 1 is there. Get cancelled, and it is a z inverse. In the denominator only the z inverse. Bring that into the numerator, z into z plus 1 by z minus 2 by 3 whole square. So the given negative powers of z, is converted into positive powers of z. X of z is equal to z into z plus 1 by z minus 2 by 3 whole square. Bring the z towards the left hand side, x of z by z. So the given function, if the negative z powers is there, first of all convert into the positive powers. Then after you can write the expression as x of z by z is equal to z plus 1 by z minus z 2 by 3 whole square. So multiple roots we have here. That is the second case. The first case we did, it is a distinct roots. So different roots. Now the second case we are taking here, that is a multiple roots. Z minus 2 by 3 whole square. That is equal to a by z minus 2 by 3 plus b by z minus 2 by 3 whole square. You can do whether it is will get directly by the d by dz or something. Otherwise, so what is the equation here? The z plus 1 by z minus 2 by 3 whole square as x of z by the z. Got it, my dear friends? So the equation is becomes z plus 1 is equal to, because the denominator get cancelled when you take the LCM here, a into z minus 2 by 3, z minus 2 by 3 plus b into, already the denominator is a z minus 2 by 3 means b into 1. Okay. Now compare the coefficients, the z coefficients, a is a z coefficient and here the z is there. So a is equal to 1. So a is equal to 1 when comparing the z coefficient. And compare the constants. Constants in the left hand side, the constant is a, not the a, sorry, 1. And in the right hand side, minus 2 by 3a plus b also. These are the constants. What is the a? We got the 1. So that is equal to 1 is equal to minus 2 by 3 into 1 plus b. So b is equal to 1 plus 2 by 3 and 3 plus 2 is a 5, 5 by 3 is a b. B is equal to 5 by 3. Got it, my dear students? See here the b is equal to 5 by 3 and a is equal to 1. Now done the equation x of z by z is equal to 1 by, since it is a, 1 by z minus 2 by 3 plus b is 5 by 3 into 1 minus 1 by z minus 2 by 3 whole square. Got it? Now after that, finding out the a and the b values, write this expression as x of z only. X of z is equal to z by z minus 2 by 3 plus 5 by 3 into z by z minus 2 by 3 whole square. Okay. So it is in the form of z by z minus a. Z by z minus a, we know the a power n into mu of n. If it is a square in the denominator, multiply the n into a power n mu of n. Still it is going on increasing z by z minus a whole cube is n into n minus 1 a power n mu of n. Got it? So inverse the transformation x of n is equal to, for this function, a power n mu of n. Because we are taking the z is greater than the value. Irrespective of the value, it is a greater than means you can take only a power n mu of n. What is the a here? 2 by 3 whole power n mu of n. In condition, 5 by 3 is multiplied with it is also in the same z by z minus a only. That is a power n mu of n, but the denominator is a square. Multiply the n into a power n mu of n. So x of n is equal to, we got 2 by 3 whole power n mu of n plus 5 by 3 n into 2 by 3 whole power n mu of n. Got it, my students? So next you go for the another example. Okay. So you completed the first method. Not the first method, second method. Partial fraction expansion method. Second method. First method we already discussed. It is a long division method or the power series method. And second method we discussed now itself, that is a partial differentiation method. And the next method is a residue method or counter integration method. Counter integration method. Okay. In this, for the given x of z, evaluate the x of n, for which the counter integral method counter integral method. So x of z is equal to z by z minus whole cube. X of z is equal to z by z minus 1 whole cube, and ROC is greater than. The poles is here see the z minus 1 whole cube is a multiple poles. Okay, the pole is equal to 1 of 3 times. So Zi is equal to 1 with the k is equal to 3. Zi is equal to 1 with k is equal to 3, my dear students. So we know the Z by Z minus 1 is a power n mu of n, and Z by Z minus 1 whole square is n into a power n mu of n, and Z minus 1 whole cube is n into n minus 1 whole power a power n mu of n. But by using this counter integration method, you have to evaluate the x of z, or to calculate the inverse z transformation. Okay. See, by using the residue method, the x of z into z power n minus 1 at its poles, sum of the residue of x of z, z power n minus 1 at its poles, that is equal to, you can write the expression 1 by k minus 1 factorial. What is a k here? Because it's a power is there, the 3 times. Dou power k minus 1 by dou z of k minus 1, z minus zi whole power k, x of z, z power n minus 1, where the z is equal to zi. Z is equal to zi, my dear students. What is a zi is equal to here? Means the pole is there, the value is a 1. Okay. Now substitute the k. K is equal to, what is the k here? 3. 1 by k is a 3 minus 1. 3 minus 1 the factorial. Dou with the 3 minus 1 by dou z, the 3 minus 1 whole multiply with z minus zi. What is the zi here? The 1. Z minus zi whole power k. What is the k value? 3 into x of z. X of z is given the z by z minus 1 whole cube. Z minus z1 whole cube, and is multiplied with the z power n minus 1. Z power n minus 1. And z is equal to zi, where at the z is equal to zi. Z is equal to 1. So 1 by 3 minus 1 is a 2 factorial. 3 minus 1 is a square. Dou square by dou z square. And here the z minus 1 whole cube and z minus 1 whole cube get cancelled. Z power n minus 1. So z means z power 1. Here you can write the 2 factors here. Z power n and the z power minus 1. So z and z power minus 1 get cancelled. We have only the z power n. Okay. For this z power n, you can apply the derivative or the partial derivative. That's 2 times. What is the first one? First derivative is n into z power n minus 1. I'm taking the dou by dou z, first derivative, n into z power n minus 1, where the z is equal to 1. And again, you can apply the derivative with respect to the z. N is a common term here. N minus 1 into z power n minus 1 minus 1. N minus 1 minus 1. See here the minus 2 minus students. Actually, z power n means n into z power n minus 1. But z power n minus 1 is n minus 1 z power. The total function is n minus 1 minus 1. So n minus 2 it is. Now we can substitute the z is equal to 1. This value is actually the 2, my dear students. Z minus 2. After substituting the z is equal to 1 here, 1 power anything is the value is a 1 only. 1. Therefore, the x of n is equal to 1 by 2 n into n minus 1. Z power anything is a 0. Not the 0, sorry. Z power n minus 2. The z is 1 here. 1 power n minus 2. The value is a 1 only. For n is greater than the 0. For n is less than the 0, the value is a 0, because it is a right hand side only. For the x of n is equal to 1 by 2 n into n minus 1 is multiplied with the mu of n, because it is n is greater than, since the magnitude is or the ROC is greater than the 1, It is multiplied with the mu of n. It is multiplied with mu of n value. Okay. By using the residue method, using this formula here, that formula is 1 by k minus 1 factorial dou power k minus 1 by dou z k minus 1 whole multiplied with z minus zi whole power k x of z into z power n minus 1. In this function, the k is the power of the denominator and the zi is equal to the pole, which the pole is repeated. That pole we are taking here. Got it, my students? See the another example, the residue method. X of z is equal to 3z inverse by 1 minus 1 by 2 z inverse whole square here, my students. So the magnitude of the ROC is greater than 1 by 4. ROC is greater than 1 by 4 means in the right side only. Right side is a mu of n, you can multiply. The given function x of z is equal to, convert it to the positive powers. Take the z inverse as a common here. Z inverse in this function, 1 by z inverse minus 1 by 2. 1 by z inverse is a z here. 1 by 2, because it is a already the z inverse is there. With this square of the term, z power minus 2 is there. Z inverse and the z inverse get cancelled, and another z inverse we have in the denominator, bring that in the numerator. It becomes of x of z is equal to 3z by z minus 1 by 2 whole square. 3z by z minus 1 by 2 whole square. Okay. So what is the formula we have? Because it is a square term of the k is equal to 2, k is equal to 2. You know the formula is here the 1 minus 2 minus 1 factorial. 1 by 2 minus 1 factorial. 1 factorial is a 1 over. No need to write this function. Dou power k minus 1, 2 minus 1, that is the first derivative of the first partial derivative. And k is equal to 2. Z minus zi whole power 2. What is the zi here? Zi is equal to 1 by 2. So no need to write the 1 by k minus 1 factorial. Actually the value is 1 by k minus 1 factorial. So k minus 1 factorial, what is the k here? 2. So 2 minus 1 factorial is a 1 factorial, no need of writing this one. And dou power k minus 1 by dou z with the k minus 1. What is the k here? The 2 minus 1, the first derivative. Whole multiply with the z minus zi whole power. What is the zi? Is 1 by 2. Okay. Zi power k and x of z, z power n minus 1, and add the z is equal to zi. This is a formula we have to find the residue method by using the residue method. What is the k? K is equal to 2. So 1 by the 2 minus 1 factorial dou power 2 minus 1 by dou z 2 minus 1 and whole multiply with the z minus, what is the zi here? 1 by 2. 1 by 2 whole square. What is the x of z? 3z by z minus 1 by 2 whole square and z power n minus 1 at z is equal to 1 by 2. So z minus 1 by 2 whole square, and here the z minus 1 by 2 whole square is get cancelled. This 1 by 2 minus 1 factorial is a 1, and dou by dou z of 3 Here the z is there and z power minus 1 get cancelled. 3z power n. 3z power n. Add the z is equal to 1 by 2. Okay. Add z is equal to 1 by 2. And now we can apply the derivative, partial derivative with respect to the z for the z power n. 3 into n, z power n minus 1. Add the z is equal to 1 by 2. What is the z is equal to 1 by 2 here? The 3n 1 by 2 whole power n minus 1. Okay. Since it is greater than the value here given, z is greater than 1 by 4, multiply with the mu of n. So x of n is equal to, for the given function, x of z, we got the inverse Z transformation is a 3n 1 by 2 whole power n minus 1 b of n. For the function x of z is equal to 3z by the z minus 1 by 2 whole square. If it is increases, still more than it is increases also, we can do by using this formula. Understood, my dear students? The next example you can see here. The x of z is equal to z by z plus 1 whole square and z plus 2 whole cube. And here the given is a 3 ROCs. One ROC is greater than and one ROC is less than, and another ROC is given here in between of 1 and 2. Means z is less than the 2 and z is greater than the 1. Okay. In the denominator, you can see here minus 1. Minus 1 is a 2 times and minus 2 is a 3 times in the denominator. Correct, my dear friends? Minus 1 is a 2 times and minus 2 is a 3 times. 2 times means here you can take this value as a k and zi is equal to minus 1. When the 3 is a k, zi is a minus 2. So two functions you can use, the residue of this function and residue of this function. Okay. The first I am taking is a first term. The first term, because it is a k is equal to 2, no need of, you can write the 1 by k minus 1 factorial, and 2 power k minus 1 is a 1 on. Okay. And it becomes of z plus 1 whole square. So z plus 1, z plus z minus z whole power k. And x of z, z power n minus 1. So z plus 1 whole square and z plus 1 whole square get cancelled. And it is at the z is equal to minus 1. It's a first residue. Got it, my dear friends? So dou by dou z of z by means here the z into z power n minus 1. Z power plus 1 and z power minus 1 get cancelled, and we have only the z power n. In the denominator, z plus 2 whole cube, and the substitute the z is equal to 1. When you can substitute the z is equal to minus 1 after applying the derivative with respect to the z here. So uv rule. Apply the u by v rule. Take the v, z plus 2 whole cube, and apply the derivative of v. Okay. What is the derivative of v here? N into n minus 1, n into z power n minus 1. Minus, take the v and write the derivative of this function. Z plus 2 whole cube. What is the z plus 2 whole cube? 3 into z plus 2. 3 into z plus 2 whole square, actually it is. Whole square, my dear students. Because the 3z plus 2 whole square, can write only the derivative of this denominator, and write the denominator is a whole square. Z plus 2 whole cube and a whole square, it becomes of the 6. Got it, my dear students? This is a square here. 3 into 3 minus 1 is a square. Here the square is there. Modify this equation. Here you have to get the square. Add the z is equal to minus 1. Now you can substitute wherever the z is there, the minus 1. So minus 1 plus 2 here. Minus 1 plus 2, that is a 1 whole cube. N into 1 power minus 1 power n minus 1 minus, and here also z power n is there, minus 1 whole cube whole power n. And here z is equal to minus 1. 2 minus 1 is a 1. 1 square is 1 only. 3 into 1 by z is equal to minus 1 means minus 1 plus 2. The 2 minus 1 is a 1. 1 power cube. 1 power 6. So finally we'll get n into minus 1 whole power n minus 1 minus of minus 1 whole power 3. That is equal to, you can write it as why we got here, it is a minus n into minus 1 whole power n minus 1. Why it is a minus means minus 1 whole power n, and minus 1, you can write this function as minus 1 whole power n minus 1 is equal to the two parts. That is minus 1 whole power n and minus 1 whole power minus 1. So minus 1 whole power minus 1 is nothing but it is a minus 1 only. So that is equal to minus of 1 minus 1 whole power n. Already the n is there. Okay, minus n minus 1 whole power n minus of minus 1 whole power n into the 3. In these two functions, the minus 1 whole power n is a common, n plus 3. Take the minus, n plus 3 minus 1 whole power n. And with the ROC is a greater than, you can multiply this a mu of n only. The first function, first residue, first part we got here. That first part is minus of n plus 3 into minus 1 whole power n, and it is multiplied with the mu of n because it is a greater than value. What it might do. And here the second part is also there. What is the second part? Minus 2 is a 3 times. Minus 2 is a 3 times. 3 times means 1 by k minus 1, nothing but the 3 minus 1 whole factorial, and dou k minus 1, 3 minus 1 is a dou square by dou z square, because it is also 3 minus 1, and z minus zi is nothing but zi is a minus 2, z minus of minus 2 is a plus 2, z plus 2 power k is a 3 here, and x of z, what is x of z? Z by z plus 1 whole square and the z plus 2 whole cube, and multiply with the z power n minus 1. Add the z is equal to, what is the z is equal to here? The minus 2. Previously we checked the minus 1 and here the minus 2. Okay. 1 by 3 minus 1 factorial means 1 by 2 factorial. We'll get 1 by 2 and it is a dou square, and before that you can get cancelled these two terms, and the z is also get cancelled with this one. So dou square by dou z square, with the numerator is a z power n and denominator is a z plus 1 square only. At z is equal to minus 2. What it might do. So for this function, now you can apply the u by v rule the 2 times. Dou by dou z and again the dou by dou z. So z plus 1 whole square into n into z power n minus 1. The first derivative you can take it as whatever we already apply here. Denominator z plus 1 whole square and n into, n into z power n minus 1 minus v, that is nothing but z power n, and denominator is a 2 into z plus 1 whole divided by z plus 1 whole square and whole square, that is nothing but the 4 will get. At z is equal to minus 1, minus 2. Again, you can check is a dou by dou z is there. Dou by dou z. Whatever the function we got now here, apply the another time the derivative. By taking off this function as one term, z plus 1 whole square here, the z plus 1 whole cube. So take this as a u by u rule, and the second term also, here the z plus 1 is there and cube will get cancelled, z power n by z plus 1. The two terms will get, for these two terms, again you can apply the u by v rule. Got it, my dear students? See how, what is the formula we get finally? See z plus 1 whole square, n into z power n minus 1, whatever we got here, z power n, 2 into z plus 1 by z plus 1 whole power 4. Got it, my dear students? You can take this z plus 1 is a common and we'll get only the cube. Here they did that. Z plus 1 is to take the common. Z plus 1 whole square, it becomes of z plus 1 n into z power n minus 1 minus, already we got the z plus 1 is a common, 2 into z power n only. And z plus 1 whole cube whole power 4. And this z plus 1 and the whole cube is get cancelled. Whole power 4 and we will get the cube. Got it, my dear students? Now again you can apply the dou by dou z of this function as a two terms. So on, you can do this. What is the final answer? The minus 2 whole power n into 0.125 n square minus 1.25 n plus 3. After substituting the z is equal to minus 2, my dear students. After substituting the z is equal to minus 2. So I will do that. See, this is a function we got. What is a function? Dou by dou z of z plus 1 z plus 1 n into z power n minus 1 minus 2 into z power n whole divided by z plus 1 whole cube only. Okay, this is a function dou by dou z. Dou by dou z. Take this function also again. You can write this dou by dou z of, and take the first function n into z power n minus 1 by z plus 1 square. Okay, minus 2 into z power n by z plus 1 whole cube. This is also dou by dou z. Dou by dou z at z is equal to minus 2. Okay, take the n is a common term because it is not with respect to the z here. First of all, we can take the z plus 1 whole square, apply for this derivative n minus 1, multiply with z power n minus 1 minus 1, nothing but minus 2, minus, keep this function as the same thing, z power n minus 1. Now apply the derivative for this one, the 2 into z plus 1. 2 into z plus 1. 2 minus 1, again you will get the 1 only. Divided by z plus 1 whole power 4. Got it, my dear students? Now I take the first term and apply the z is equal to minus 2. You can substitute the z is equal to minus 2 there. After substituting the minus 2 here, n into minus 2. 1 minus 2 means minus 1 whole square. The value is a 1. So n into n minus 1. Sorry. N minus 1 and minus 2 whole power n minus 2 minus, again here the minus 2 whole power n minus 1, the 2 into minus 2 plus 1. It is a value is a minus. Minus, I am taking here the plus 1. The 2 by minus 2 plus 1 is a minus 1. Minus 1 whole power 4 is, because the power is an even term, the value is a plus 1 only. Okay, plus 1. So still you can simplify the minus 2 whole power n minus 1 here and the minus 2 whole power n minus 1. In the both the terms, the minus 2 whole power n minus 1 you can take as a common. Minus 2 whole power minus 1 is there. Minus 2 whole power minus 1. N into n minus 1 minus 2 whole power minus 1. Or otherwise you can simply leave it this function like this. Or you can rewrite the n into and take the n minus 1 whole multiply with the minus 2 whole power minus 1, because you can write this as n minus 1 minus 2 whole power minus 1 and plus 2 whole multiply with the minus 2 whole power minus of or n minus 1. This is the equation. What it might students? What is a minus 2 whole power minus 1? Minus 2 whole power minus 1 is a 1 by minus 2. 1 by minus 2. So divided we will get the minus 2 values there. Still you can simplify this value also. What it might students? The second term we can take here. What is the second term? Dou by dou z of 2 z power n by z plus 1 whole power cube. Whole power cube. Already we did that is a z power n by z plus 1 whole cube. Okay. So let us see that also z plus 1 whole cube into only the 2 is there. Before that the 2 is multiplied. N into z power n minus 1 minus, write the z power n, 3 into z plus 1 whole square, and denominator it is z plus 1 whole cube. Not the whole cube, already whole cube means it is the 6, power 6. And z is equal to, we can substitute minus 2. 2 into minus 2 plus 1. Minus 2 plus 1 is a minus 1. Minus 1 whole cube is a minus n into minus 2 whole power n minus 1 and minus 2 whole power n minus 2 whole power n and 3 into, here the minus 2 plus 1 is a minus 2, minus 1 whole square is a value is a 1 and denominator minus 2 plus 1 is a minus 1 whole power 6, minus 1 whole power 6 is again the value is a plus 1 plus 1. The 2 into this function. Simplify this function. 2n into minus 2 whole power n minus 1 minus of minus 2 power l power n minus 2 whole power n into 3 and so on. See the minus 2 whole power n and the function is multiplied with the n square because it's n into n is there. N into n. The function is again the minus 2 whole power n. All the terms we have the minus 2 whole power n is there here, and minus 2 whole power n is there. And in this function also minus 2 whole power n is there, and here also the minus 2 whole power n. Forget about this equation here. What I wrote, this is the first term and this one is the second term. Got it, my dear students? So in all the terms, this term is a minus 2 whole power n, minus 2 whole power n, and minus 2 whole power n is a common. Got it? And what is the remaining functions? Here the 2 is there, and here the minus 2 whole power n is there. It becomes of 3. That is the last term is a 3. And 1.25 because it's a minus 2 whole power minus 1 the value. And here the another term is there, minus 2 whole power minus 2, that is the value is 0.125, and the denominator, and it is a square of the term, n square, and it is a n into n means 1 square. So finally this answer will get, after multiplying this with the n and 2 with this function, you can add the 2 terms, not the addition, my dear students. In between there is a minus is there, minus term. That minus is becomes here the plus, and this also the plus. That plus only the last 3 will get here after taking the common of a minus 2 whole power again. Okay. Got it, my dear students? So finally we got this function, and it is multiplied with a mu of n. Why it is a mu of n? It is a greater than the 2. Greater than the 2 function, my dear students. In previous we got one term, the first term, and in the second term we can add these 2, add the 2 functions, add the 2 functions to get the x of n is equal to this. X of n is equal to minus of n plus 3 minus 1 whole power n mu of n, and this is a term equation 2 also. What we got in the previously, minus of n plus 3 minus 1 whole power n, and in this second term we got minus 2 whole power n, would multiply with the 0.125 n square minus 1.25 n plus 3. It is for only the z is greater than the 2, and z is less than 1, and the z is in between of the function means less than. You can change these values, mu of n as a mu of minus n minus 1. Mu of minus n minus 1, you can multiply and keep the minus. And for this function also, the mu of, instead of mu of n, mu of minus n minus 1, before that you can keep the minus value. It becomes of a left-sided function. And in the third case, z is greater than 1 and z is less than the 2. So 2 power n is a minus 1 whole power n. Now it is depends upon the value. Z is greater than 1 means 1 you can take it as a mu of n. Z is less than the 2 means minus 2 whole power n, whatever it is z is multiplied with the mu of minus n minus 1. So all the 3 cases we got. When greater than the 1, 2 means multiply with the 2 terms with the mu of n. Less than the 1 means multiply both the terms with the mu of minus n minus 1, mu of minus n minus 1. Within the range is there, z is greater than and z is less than. For greater than, you can take as mu of n. Where you have to multiply the mu of n means the value what we have here. Z is greater than the 1 is minus 1 whole power n is there. And z is less than the 2. Wherever the 2 is there, the term minus 2 whole power n, you can multiply this mu of minus n minus 1. Got it, my dear students? So there is a residue method. Next, in tomorrow case, we can see the last method, the convolution method. By using the convolution method, we have the 2 or the 3 examples we have. Tomorrow's class, we can see the convolution method. So any doubts, my dear students? Okay, thank you.